Okay, so let's look at 22. It says a group of hikers has gone missing somewhere in the region around base camp at the origin on the graph. And they put O. O for origin, right? A search party leaves base camp and travels along the following vector paths in order to track down the hikers' whereabouts. So it shows you in the data table over here the different vectors that they traveled. Okay. So they traveled initially a distance 7.07 kilometers at an angle of 8.13 degrees. So we could figure out where they ended up by doing the two different components of this. So how would we figure out the components of that vector? Yeah, so to figure out the x component, we would want to go, I guess it's displacement, so I should use d's, not b's. Let me change my notation there real quick. Okay, so let's do the x component by saying it is the resultant multiplied by the cosine of the angle. So what would that be in this case? Well, that would be 7.07 times the cosine, let's do, of 8.13. And what does that end up giving you? 6.99. Basically 7, right? Okay, so 7. And then we could do the same thing for y. So we get basically 7 right there. And we do the same thing for y. 7.07 times the sine of 8.13, and we get 0.999, so 1. So we know that they walked 7 kilometers this way. 1, 2, 3, 4, 5, 6, 7 kilometers to the east and 1 kilometer north, and ended up right there, and this is where a straight edge helps out. Okay, so we would just draw A here. So there's A. Does that make sense? See how to solve that? And you're just going to repeat that process for B and C. So let me come around and see how y'all did with that. Okay, so they're looking good. Let's see, the answers here were negative 14 and 3 and 4 and negative 14 for C. So to find where they ended up at, all we have to do is add all of those up. So if we, oh shoot, I put the wrong ones there. I'm sorry. You guys should have been like, Mr. Flint, what are you doing?
Okay, I was starting to say, it's like, did I just get that far wrong?
I was looking at the wrong thing. I was like, whoops, that's the wrong number I'm looking at. 13, negative 13, and 4. And we want to go 2 and negative 12. Okay. So now that I have the correct numbers up here, let's add those up. 7 and negative 13 is negative 6, right? And then plus 2 should be negative 4. 1 and 4 is 5, plus a negative 12 would give us negative 7. So then next says draw the vectors on the diagram to the left showing the path the search party takes and the position of the hikers Okay, so we're going to do that each point in time. So at A, they ended up over here, and then let's draw B. So they went back negative 13, so let's count back 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then positive 4. 1, 2, 3, 4. Okay, so went up 4. So if it went up 4, why did I draw it on 5? Well, it's because back on A, they'd already gone up 1, and I'm drawing this from A, not from the origin. Okay, so B is drawn starting at A. So we're just drawing tip to tail. And then for C, we want to go positive 2, so 1, 2 in the x direction, and then negative 12. So there's 5. There is 10, 11, 12, so we should end up right here. Okay, and it's much easier if you have a straight edge to draw these really pretty. Oops, see, I missed. But you know it's supposed to end up here. Okay. I'll try one more time just to see if I can't hit it a little bit better.
B's supposed to go to 4 or 5.
There you go. And there is C. And that puts our resultant in this direction, and that's where we get the negative 4, negative 7. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. So the resultant is right there when we add those up. Okay, so there is our resultant, and I'm just gonna say it's our displacement resultant. You could put a D, you could put an R on that. So if the search party was able to cover 3 kilometers of distance every hour, how many hours did it take for them to find the hikers? Right, well, we come back up here, add their distances up here. Is that what you're saying?
Yeah.
Okay, yeah, so add all these things up, so then we know the total distance, right?
Yeah.
All right, so what is that total distance?
That is
32.74, right? Kilometers. So the total distance that they went was 32.74 kilometers. They're able to cover 3 kilometers every hour. How many hours did it take? So divide that by 3 kilometers per hour. So distance divided by the speed gives us the time. And we should come out with almost 11, right? 10.9. So yeah, add the numbers that I put in the box together, and you get 32.74. So that's the total distance that they walked divided by their speed, and that gives you their time, how long it took to walk that far. So they were out searching for 11 hours before they found them. Okay. Basically, 10.9, but 11. Now, let's look at the very last one, D, on here. Let's go to D. The search party finds that the hikers are injured and also radio for a helicopter to airlift the hikers to a hospital. The helicopter and hospital are located at base camp, and the helicopter can stay in the air only 30 minutes due to fuel limitations, and it can fly with a speed of 1 kilometer per minute. What is the maximum amount of time the helicopter can spend at the hiker's location in order to make it back to base camp before fuel runs out? So how long can it spend in the air? It can only spend 30 minutes in the air, right? Okay, so there's our maximum amount of time in the air. and it travels 1 kilometer per minute. So we know the speed. Okay, so the velocity of that is 1 kilometer per minute. And how far is it out to the site? How far is it from the base camp to the site where the hikers were found? Yeah, we've got to find that. We've got to find that vector distance. How far is it? How would we figure that out? Square root of the horizontal displacement plus the square root of the vertical displacement, right? Sorry. The square root of the horizontal displacement squared plus the vertical displacement squared. So we want to make sure to plug in your numbers there. What was the x value? We don't really care about positives and negatives right now. Why don't we care about positives and negatives? Yeah, we just care about an absolute value distance. We don't care about a direction in this case. G squared plus 7 squared. So let's just simplify it and take the negatives away already. So they don't confuse us. So that's really 16 plus 49. And when we do 16 plus 49, what do we come up with? 75? 65? Thank you. And the square root of 65 is? Is that right? Okay, so we get 8.06. So it is that far from the origin, okay? If I back up, it's that far from the base camp out to where they found the hikers here at C. Okay, so here's C over here, and that is 8.06 kilometers away. Well, it's 8.06 kilometers out and back. So we've got to make sure to multiply that by 2. So that helicopter has to be able to fly not just 8.06, but 16.12 kilometers. So we've got to make sure that's our total. That's really the total distance that that helicopter is flying. So now that we know that, it's going to take 1 kilometer per minute. So how long is it going to spend going out there? How many minutes?
8 minutes. Going out there.
8 minutes going, 8.06 minutes going out, 8.06 minutes going, so 16.212 minutes, right? 16.12 minutes flying in the air. So then how long can it spend hovering out there? Good. Subtract that, and let's just round that to 16, so let's just say 14 minutes, okay? Now, it's actually going to be slightly less than that, so they need to make sure to spend just under that, because if they actually spend 14 minutes, then the helicopter will run out of fuel. So,
And you'd be cutting it rather close for landing back.
And also something happens on the way back, so they want to make sure to not spend more than 13.9 minutes there. They probably were going to want to spend about maybe 10 minutes. So that'll give them 4 minutes of safe time there. Okay.